everyone, my name is Adrienne Tacke and I'm a Senior Developer Advocate for MongoDB. Today I'd like to talk to you about getting up and running with Azure DevOps. Now I've used Azure for quite a bit of my career, so I'm pretty excited to share with you all some of the best practices that I've learned with my team using Azure DevOps to build good CI/CD pipelines. Let's get started. So usually the first question that we all ask ourselves is, what's in a pipeline? What actually goes through this magic that automatically builds our platform and deploys it out into the world? And as we started talking about this amongst our teams, we found that we would share, things that worked, things that didn't, things that other teams are doing that sounded cool, things that we would like to have that were pain points in our existing processes. And when we put all of those together, we found that we really needed to rephrase this question from what's in a pipeline to what's in a good pipeline. And so after much discussion, much trial and error, and seeing what works and tweaking things, I want to share with you some of the things that I have learned with my team that have made a good pipeline that is sort of a reference for what I use now if I ever needed to build my own CI/CD pipeline again. We all pretty much agreed that the first thing involved in a good pipeline is some branch policies. So when we start our software development workflow and when we actually start the pipeline and the automated part of it, we want to make sure that we start with something good, something pristine, something clean. And when we talk about that in the context of code, we know that this means that we need to protect the branches that our code lives. As so many people are making changes, or maybe we ourselves make some mistakes, or maybe someone's unfamiliar with some Git branching strategies, there are a lot of possibilities that could either ruin the branches or just make it a little bit messy. And those are usually the cause for bugs or for things breaking or other things that are usually scary that we don't want to happen. Now, in order for us to start, we need to protect our branches. So in order for us to even begin thinking of an automated pipeline, we need to make sure the source is good from the start. So what are some things we can do to do that? Well, the first thing is to decide on a branching workflow as a team. It's super important to have everybody on the same page, and that way we all know what the workflow is going to be. The second part of that is to limit the kind of merge types that we're going to have into our branches. There could be different ones for different branches. My team only liked to do squash merges into our dev branch, because when we used feature branches to work on things or hotfix branches to work on bug fixes, we sometimes might make multiple commits on those branches. But in the end, once they got merged into dev, we didn't want to clutter up that history with all of our commits. So we decided as a team to have only squash and merge be the type of merge that could be allowed on our dev branch. And if that's something that can be enforced, it should, and it should be set at the branch level. You want to keep main branches free from direct commits. So this is the equivalent of don't work on production, or don't let anybody work off of the master branch if that's the one that you're using as your production branch or your main branch. And again, by setting up a pipeline and setting up policies to make sure this happens, one of those things that you can do is set it at the branch level, where you protect specific branches to not have direct commits be allowed on them. Another thing is to avoid committing dependencies. So much like not wanting to litter up our history, our Git log history, with multiple commits, we also don't want to litter our source code with any dependencies that don't belong there. They can blow up the size of our repository, and they're usually something that we can add later on in the build process and don't need to be part of the source code. And finally, we want to remove configuration files where possible. In this case, it should be fairly possible for most things that you want to configure. And the reason this is important is that this usually holds user level secrets or connection strings or things that are configurable and will differ. And if you check that in, well, you're always going to have a conflict when somebody else checks that out and sees your code or your connection string or your local settings. So we want to remove those out and actually replace them with somewhere else in the pipeline, which we can get to in a bit. So now that our branches are protected, now that we're sure that our source code is as clean and in pristine condition as it can be, the next thing that we want to double check is our pull request policies. So we want to strengthen our pull requests. Now we know we're on the same page. We want to make sure our code is as good as it can be, but as developers, we all know that, well, we should be having some pull requests to double check any new changes that are coming in. So with this process, there are still things that we can do to help our pipeline. The first of which is to set a minimum number of reviewers. I have a different talk I give and talks about code reviews, where a lot of the pain points, it was a pain point in our team, was having some bias in our code review process or pull request process, where people were approving their own pull requests, or buddies were approving each other's pull requests. So we wanted to cut that out, and one way we could do that is to set the minimum number of reviewers. In our case, we set it to the entire team because we were a small team. And but for other teams, if you have a larger team, you may just set it to at least 2 people or at least 3 people, depending on what your team requirements are. The next thing to do to really strengthen our pull requests is to enforce linked work items or ticket numbers. So if you're using Jira or GitHub, or like we were using Azure repos, we would make it required to have whatever change that we were about to merge in be tied to a vetted ticket or something that everyone knows is something that is needed. And this is one way to cut out any potential code that was not needed or was just not vetted at all, or maybe it was just a proof of concept somebody wanted to put in. As long as we could tie it to some enforceable ticket number, it was another way to help protect the code that we were about to merge and potentially deploy, knowing that it is something that was needed. Run pre-builds. I can't stress this enough. So many bugs and issues or things breaking have been saved by this one little step, which is, if you've used GitHub before, you'll see that when you open a pull request, and if the maintainers have set it up that way, it actually runs a dry run, a pre-build, to see if the changes that you're about to merge in are actually good and won't break the build. So in the same fashion, if you can do that in your pipelines, I highly suggest doing that, because it's, again, another step that you can double check that the changes you're about to commit will work and won't break the build. And if it does fail on the pre-build, well, you have a chance to fix it before it actually goes further into the pipeline. Auto add reviewers, kind of the buddy to setting the number of minimum reviewers. If you have particular pieces of your platform that have specific people who may be better suited to look at that code, make sure to have those people automatically added. We do pull requests all the time, and so that could get really, really tedious to always add them in your pull requests. But if you're using a system like Azure DevOps, they actually give you the option to add auto add reviewers. So that cuts down on your time searching for people, and it also cuts down, again, on the bias for just only having specific reviewers look at code. By auto adding reviewers, you can auto add everybody or auto add your whole team and make sure everybody sees the code that is about to be committed. And finally, one really good thing that you should enforce and have on is to have comment resolution. What this is let's say you have a pull request and people are looking at it, hopefully do diligently, and they see something that they have a question on, or they have a valid concern about a particular piece in the code. Usually when this happens, you leave a comment. And what checking for comment resolutions does by enforcing that is that somebody actually acknowledges that they've seen the comment, that either something has been done about it, or that they have seen the concern of the other person and is just acknowledging the fact that they know something was brought up. Without having this, some people could possibly have some concerns but approve the pull request anyway, and that's just another source of potentially merging in something that we don't want. So again, this is just another check to make sure that the resolution has been found. So protecting our branches and strengthening our pull requests. All of those things that I just mentioned, we can pretty much set up in just about 1.5 minutes, and it's pretty cool, and it's part of the reason why I'm so happy I worked with Azure DevOps. So just to show you, this is a minute, and what we wanted to do here is go to one of our branches in Azure repo, and you'll see here I'm going to go to my dev branch and go onto the little side menu and click on branch policies. And the beauty of Azure DevOps is that, look at that, everything that I just mentioned of protecting branches, strengthening pull requests, you can set up right here. Requiring minimum reviewers is a checkbox. You can set the number. You want to make sure that linked work items are checked for and that making it required. Checking comment resolution is also a checkbox. And here, limiting the merge types, you can do that as well in Azure DevOps. And as I alluded to, we only wanted squash merge, so that's the only one I wanted for dev. The build validation, which I'm setting up here now, is the pre-build. So for the build pipeline on my dev branch, I want to make sure that is run. And now to automatically include reviewers, I'm searching for myself here. We don't want to do that. I'm the only one on here, so that's why I'm searching. But you would automatically add reviewers just like that. And you could add more, you can add less, you can add a group. And in just about 1.5 minutes, everything that I just explained was just set up for this particular repo. And that's super powerful and super important, because now with all of those things in place, they set the stage for our pipeline to be as clean and as repeatable and as a good automated process as possible. So now, once we've had all that set up, it's actually now time to kick off that automated build that we wanted. So what happens in the build process? Well, to start, we start with our code, right? Once all those things have been passed and it's successful and the pull request has been merged, well, that triggers a new build. New changes, that's the most common way to trigger a build, I should say. There are different ways you can, but in the simplest example, new changes would trigger a new build to start. And once the build goes through, if it's successful, it creates an artifact for us. And that artifact is something, you can think of it as a nice little package that our release pipeline can then use to deploy to the world. It kind of has everything that our platform needs to be deployed. So logically following that is the automated release. If our build was successful, the next thing we most likely want to do is release our code into the world. So what is the release process? Well, again, the new build that has just been finished would trigger a new release. And then in Azure DevOps at least, and I'm sure other pipeline tools and platforms can do this, but the next thing is if you have any pre-deployment conditions, it would make sure those all pass before it actually goes out and does its thing, which is the third step, and that would be deploying to the environment that is configured for that particular release pipeline. And then just like the pre-deployment conditions, Azure DevOps also offers post-deployment conditions to really make sure that anything else needed after the deployment is successful. So you heard me talking about pre and post-deployment conditions, but you're probably wondering, what are those? Well, I like to think of them as things that help secure our deployments. So now that we're automating our deployments and our builds and our whole pipeline in general, that can get kind of scary, especially for some companies where they may not want to automate everything, or there are processes in our workflow that might require human intervention. So these are things that, being aware of the automated fashion of the pipeline, that we want to kind of build in and just help us feel more at ease That's why I like to think of it as securing our deployments. So what does that mean? Well, we can add pre and post deployment conditions to match our workflow. For our particular workflow, we added pre-deployment approvals, and it's something I highly encourage you to also do. What pre-deployment approvals we used were, we had a dev environment, and you'll see in a bit we had a QA environment, and what we did for one pre-deployment approval is to make sure that at least one person on the engineering team actually gave an approval to say, hey, everything is working on the dev environment. Dev environment was separate from our local environment. So this is kind of the first check to say, yes, everything is looking the way that it's supposed to. And we gave that pre-deployment approval before it went into the QA stage. Artifact filters are another great way to secure deployments. So the simplest pipeline that I'm showing you now is just going through and building and releasing in a straightforward fashion for the entire platform, or in this case, the demo I'm about to show you. But you can get much more complex filters for that. For example, if you only want to deploy something if it's part of a particular project, or if you separate some parts of your system, maybe from front end to back end, or you only change the API, or you only change this particular component for the Internet Explorer or Edge browser, and you didn't want to do a full deployment for that. You can use artifact filters to search for either the path of the folder that you want to trigger that deployment, or you can search for the actual project name, or maybe a tag, or maybe a version, something else that you are specifically looking for and will be the condition for you to only then release. Another thing that you want to decide as a team that would help secure your deployments are to decide what the deployment queue settings are. So if you work on a team, you most likely will have multiple deployments queued at the same time, especially if you're working pretty fast and you're pushing out changes and you're just on fire. You're going to have a lot of them queued up, and it's important to decide whether you want all of those sequentially to be deployed one after the other, which can be what you need sometimes, especially if you're very compliance heavy, or if you want to save a little bit of time and resources, you can cancel all the particular deployments that are queued and only deploy the latest one that has been executed. Again, these depend on your team and the platform that you're working on. And finally, one of the really cool things about Azure DevOps is that they have something called gates. Now, gates are a way to check for other things outside of Azure DevOps that you may need to consider before actually deploying. One example is connecting or making a call to Azure Monitor and saying, hey, is our environment actually ready for a deployment? You may make a call there and double check that you are not currently on maintenance time or not doing another deployment, and only if it's a successful return on that call do you actually move forward with your deployment. Or maybe you want to invoke an Azure function and do some logging, and only when that is successful do you actually then want to move on with the deployment. These are the types of things you can do with gates, and a way for you to check different statuses before fully continuing on with your deployment. And lastly, I've alluded to it, but the very last part of what we think a good pipeline involves is a multi-stage deployment. So in its simplest form, we have something like this. We have a dev stage, a QA stage, and a production stage. And the stages I like to think of as environments. That's the way I have set it up here in Azure DevOps. Now, if I get my little pointer here, you'll see here, this is the dev stage I alluded to. And this is where you would set up your pre-deployment conditions. And this is where you would set up your post-deployment conditions. Now, when you click on each of these little buttons here, you have the opportunity to set those up for each stage, you'll see here. And you have that flexibility for each stage that you want to deploy to. And this is the simplest form of a multi-stage deployment. And so now I hopefully want to show you a demo where I have built all this out And so cross your fingers for me that this works. So let us go. Now, this is the very simple website that I have here, and you'll see that we have this hello there Obi-Wan GIF. And what I want to do is I have our application ready here, and I want to change it to this particular GIF because I just recently started my job at MongoDB. So I wanted to find a nice MongoDB GIF here to kind of share in my excitement. So I'm going to change that. I'm going to change the alter text since it's no longer that. So MongoDB GIF. And that's pretty much it. So now I'm going to have this set up. Let me make this larger. So if I do a get status on here, we'll see that my index has indeed changed. So I'm going to commit this, add it and commit it. And I'm going to say update GIF to MongoDB GIF because I like to be a little explicit in my commits. So now it's that, and now all I have to do is do a git push. And if everything goes according to plan, this should kick off our build. So this is where I want you to cross your fingers for me. So we'll see here, I have this pipeline. If we refresh this, wonderful, it has kicked off. We'll ignore that. That's something about one of the build agents expiring a version. And so what's really cool about this is as your builds are running, you can actually click in here, go through and see each of the steps of what's happening in your build. So for us, this might take a little bit of time. Might be a little slower, especially now that everyone's working from home, but keep crossing your fingers for me. So what's happening right now is it's going through all the steps that have been outlined in my build process. That's using NuGet Restore to get any of the packages I need from my application. Then it's going to build the solution. Awesome, we're doing great so far. And after it builds the solution, it will run through any test assemblies that you have. Awesome, solution's built. Run through any tests, we'll publish the symbols, and there's that artifact that we're hoping for, which is awesome. And cool, so now that is gone through. So now we can go to our release, and it was finalizing. Let's stop that. Might still be, oh no, it's successful. So now let's just wait for our release, which should be kicking off. Might take a little while since, again, there are many people working from home, so let's see. This was last night, so that's not it. Let's just double check that it actually did deploy. Nope, not yet. So what we would expect is a new release to be coming up right here. Now let's double check that this is gone. And oh, there we go. See, just needed to wait a little bit. So as you'll see here, we have our release and I have my stages as I've shown. And we'll see here now that dev is queued. So what's happening now is it did trigger this release because our build was successful. So it is now queuing to deploy to the dev stage, and it might take a little bit longer, but we can actually click in here to see what is happening. So it is in progress. And you'll see here that this was our artifact, right, from our DevOps dev build that was just successful that I showed. And now it is deploying to the Azure App Service that I have ready that is hosting my application. So once this is done, we should be able to refresh that DevOps demo page, and it should show us our new MongoDB GIF. Let's give it a little time. It's deploying, it's working. Woo, succeeded. So big drum roll. I'm gonna make it a little larger, refresh this, and it should be a MongoDB GIF. Yay! So that is our slogan, think big, go far. And that's an example of how from pushing a commit, how I did not touch anything else, and it has automatically deployed with automatic tests built in, with our build automated, and everything that I just spoke about, all done in one place. And I think that is really, really cool and really powerful, especially if you want to start getting more and more releases and delivering value to your customers a lot faster in a timely fashion. So let's go back here. So thank you for crossing your fingers for me. It worked. And that's all I have. Salamat. That is thank you in Tagalog. You can find me at any of these social media channels or on my website, adrienne.io. And I will be here. Please ask me a question in the chat. I can't wait to talk to you all. Thank you so much.